Hey everyone, so I wanted to give you a potential solution to that previous project we had. So first thing we want to do is I want to create some constants. So like we said, our track width is going to have to be between 4 and 12 inches, and this is going to have to be between negative 100 and 100 inches. So first I want to create some constants up here just so that we don't have any magic numbers in our program. And so let's try that first. So we're going to say final. And for the track width, we're gonna do it as a float. So final float track width min equals, and we're gonna say it is 4 inches. And we're gonna do the exact same thing for the next one. So final float track width max equals 12 inches. And we're gonna do the same thing for the other two. So our other two are wheel velocity min, and we're going to say that that is negative 100, and our max is going to be positive 100. One thing you might want to do also is actually put underscore inches on all of these. Inches, and then inches per second, or per second, I'm sorry, you just say inches per second. I'm going to personally leave this out because I think we kind of make it obvious in other places right here that we're measuring in inches, but you could also do this. Really, I think the most ideal solution would be to use an inch type and a float type, or not an inch type and an inch per second type, and we're going to discuss like how to create your own types, but that is for a later tutorial whenever we're going over object-oriented programming in Java. So for now, we have all of these types right here, and I'm sorry, all of these constants right here, and we're going to then use these constants to make more fallible code. First, we want to, instead of making our track width equals scanner.nextFloat, I don't know if you remember, but in our last video, we discussed how using nextFloat can be problematic because whenever you're using nextFloat, that can cause the what's it called, the scanner object to basically break, and it can cause it to infinitely fail. So what we're going to do instead is create an infinite looping loop using while true, and it's obviously going to have to break, so we can't ever forget to break. And we're basically going to be checking for a bunch of conditions instead. So first thing we want to do is create an input variable. So we're going to say string input equals scanner.next line. And of course we have to remember to trim this, or else our string will not be formatted correctly. So we want to have our string formatted well. Then we're going to try parsing it. So try, and we're going to say input dot sorry, my bad. We're going to say track width equals float dot parse float, and we're going to use our input. So one of the things I do want to point out is this float type. I never explicitly said that this existed. What we're showing you, this is a class. I never said that this existed because I wanted hopefully you to be able to imply that it came from integer. So hopefully you were able to figure that out on your own. So now this part float right here, parse float, can have two potential throwing errors. We're not going to worry about this null and only worry about the other number format exception. So we're going to go catch number format exception, and we're going to ignore it. So I'm going to say ignored. And here we want to provide our users with a useful message. So we're going to say um, the oh, and also before I do that, I want to make sure that I am telling the user the constraints first. This is just something I forgot. So we're going to say please enter the track width of the robot, and we could say between 4 and 12 inches. But one thing we can actually do to make our code more fallible for the future is like this, and then we could say plus track width min, and I'm going to make this actually a new line. So we're going to say print ln, and then we're going to have our print, and we're going to have our, right here, make input between, and we're going to say right here, So we're going to go plus track width min, and we need to have our spaces here, plus, and we're going to say track width max plus inches, like this. We'll take all this out right here. Don't forget that, and we're going to put our colon. So just like this. And this line is getting a little bit long. It's almost coming off my screen, but yeah. So we're going to say between track with min and track with max inches. This right here, the reason I did it like this is because now we can update this to 5, and it will automatically update it. So even inside of strings, you want to make sure you're not using magic numbers. This is one of the reasons why magic numbers can be dangerous. And this applies to just about anything. It can even happen in comments. So that's one of the reasons why you got to be careful with comments. Make sure you can even have magic numbers in comments. They can be in strings, anything like that. Just be careful with magic numbers. So anyways, we have that right here. And now I want to print out track width was not between, and we're going to say right here, take this, and then inches. Just like that. This line's getting a little bit too long, so I'm going to, it's coming off my screen, so I really need to put it on a new line. But this is still, Java parses this as one line because there's only one semicolon. So track width is not between our parameters, and we're going to say system.out.println, and we're going to say, oh, we only want to print, please re-enter the input. Perfect. And after this, we're going to need to continue. So that's going to go back and redo this. Lastly, we're going to need to do our bounds check. So we're going to say if track width, because if you remember this catch, it's going to continue. So this is not going to be evaluated, even though it's 0 right here. This continue is going to cause it to go back up to the beginning and try again. So if track width is greater than track width max, or track width is less than track width min, just like that, we're going to want to do the same type of thing. So we're going to say, I just realized this right here, I am very dumb. This needs to go here. I'm sure someone noticed that besides me. Okay, I hope someone noticed that besides me. So we're going to go, input was not a valid floating point number. Just like that. I am so sorry about that. Okay, track width was between these parameters, and then we're going to do the exact same thing right here. Please re-enter, continue, and so that's going to prompt them to enter using that thing, and it's just going to be the same. So this little block right here, we're going to be repeating a few times. So let's first make sure our constraints are updated. So right here, we're going to say, please enter the front left velocity of the front left wheel. We're going to make this an ln, and we're going to say, do the same type of thing we did up here, and we have the colon up here, but instead we're going to say inches per second, and update these to be this, and this. Where is it? Here you are. Lastly, we can take this right here, and I'm sorry I'm bouncing around kind of a lot, put that there, and I've forgotten to take this right here as well. So this is the front left velocity, and we're going to need to update every instance of track width down here to say front left velocity, so I'll do that really quick right here. Oopsie. You can see I'm already getting a little bit lost myself here. Front left velocity. These look so similar. Perfect. Then we can do the same thing for all the rest of them. And I'm taking the printlns just to make sure we're copying absolutely everything. Just like that. Front right. Front right, update all of these. I'm sure by now you can see the why we need to learn some of these processes to simplify our code. This is getting very, very long. So this is going to be the back left, and this is going to be the back left velocity. And in the next tutorial, we will be discussing how we can simplify this code a lot to make it significantly more readable. So this is going to be the back right velocity. Back right, back right, back right, back right. Let's hope I didn't miss any of those. Those look good, those look good, those look good, and those look good. Okay, let's make sure our formula is still correct. So it's back right plus front left minus back left minus minus front left minus back left. Okay, that is all correct. That is perfect. Okay, and you can see our code has gotten pretty long, 136 lines. So let's try it out. Let's see if it works. It's so important to test your code. I've actually had, you can kind of see up here, I had to try this a few times myself because we're humans and it's easy to make mistakes. Okay, please enter the track width of the robot between 4 and 12 inches. So let's try something not between it. The track width was not between. Let's try this. That was not a valid floating point. What about 4? Perfect. Please enter it between, whoa. I've seen a little issue already. Perfect. Let's try this one more time. Okay, please re-enter the input. We're going to try 4. Okay, let's try 100. What's happened here? Ah, I see. We're not checking for our velocities, we're checking for the track widths. This is why it's so important to test your code. So we're going to go back here. So for the first one, we're checking for the track widths, but this one, we need to be checking for the velocities. So velocity min, this one's going to be velocity max, and we got to do it down here as well, and here as well. And we need to do that same thing for every single one. So velocity min, or velocity, wait, is it max first? Yeah, if it's greater than max or less than min. Yeah, greater than max or less than, max goes here. Did I do that? Okay, I see what I did here. Because they swap like that. Okay. So we know max, max, and this is going to be min. Velocity min. Velocity min. Same thing for the next one. Velocity min and velocity min. Once again. Min. That should be good. Okay, let's test our code again. And again, this is the reason why it is so important to test your code. It's so easy to make a mistake. So we're going to go 4, 100, negative 100, 100, negative 100. And it says our robot is rotating 1,432 degrees per second. And that was with a track width of 4. So let's see what happens if we had a track width of 12. Let's try it again. So we're going to say 12, 100, negative 100, 100, negative 100. Perfect. And we're going to try things out of bounds again. So we'll try this one. We'll try 13. That doesn't work. 12. Perfect. 101. Doesn't work. 100.1. Doesn't work. That looks like it looks good to me. So this is one potential solution. Of course, we can make this a lot more simple, and we're going to be discussing that, how to make this code a lot more readable because there's so much repeated code in here. We're discuss how we can make this a lot more readable in the next video. And there are so many ways you could have had this. I'm guessing that your code probably doesn't look like this. Anyways, that was about enough for this tutorial. I hope this is helpful, and this has been a very long video, but I hope this has been very helpful.